Hello, in this video I'm going to make Tic Tac Toe as a WinForms project. Tic Tac Toe is just an excuse to use a two-dimensional array. Two-dimensional arrays are useful for modeling data that is tabular in nature, things where you have two x's or indexes like maybe gender and age, and those two indexes reference expected height or an average weight or something like that. There's a lot of times where we have data that is sort of easily represented as a table. A two-dimensional array is a great data structure for doing that. So let's just start here. I'm going to change the text on my form to be Tic Tac Toe. There we go. And then I'm going to give myself a menu bar, view, toolbox, menu strip. And let's drag that on there. And I'll give myself a file menu that has a reset option. And how about an exit option? Ampersand XIT. There we go. And then I'm going to double click on my exit and say application.exit, and I'm done. Okay, so there's my exit menu. Now what should I do? Well, let me think. Let me go put a button on my form here, because what we're going to do is make 3 buttons. That's going to be what the player clicks on. So let's pull up the toolbox, view, toolbox, button, drag a button on here, and I'm going to go set its size to be 100 by 100 or 75 by 75 or something. I think I'm going to set mine to 75 by 75 just because. Is that right? It doesn't look right. Okay, I guess that's right. And then let's do some other stuff to the button to make it just a little bit prettier. I'm going to set its back color attribute. There's back color. I'm going to click on the little area next to it and select web white. So now my button is white, and I want to change the font color too. So let me go into the font property here. I'm going to set the font property to be 72. All right. And why is the letter B there? Well, that's the B that's in button, and it's just, they can't fit any other letters. So let's just come down here to the text property and set the text property to be blank. Just hit delete. Okay, there's our button. And then let's double click on this button here. To create the handler for it. Now what we'll do is we're going to go make the 8 remaining buttons, and we're going to wire them all up to the same handler. So we're not going to have 9 different button click functions. We're going to have one, and they're all going to map to it. It'll make our lives a lot easier. So I'm going to copy and paste this button, but I have to do it in just the right order to make sure that the numbers or the names of the controls follow a pattern. Because what we're going to do, we're going to be sneaky. Our controls are numbered. We have button 1 through button 9. We're just going to chop the last character off the button name, turn that into a number, and that's going to be our control. And once we have the number of the control, then we can use that to figure out its row and column by dividing by 3 and doing a modulus by 3. Modulus will give us the row. Division will give us the column. No, I got that wrong. The x-coordinate. The modulus gives you the x-coordinate, which is the column, and just doing a regular division will give you the row, which is the y. All right, so there are our buttons. Now I'm going to control click on all of these guys, select them all at once, and then I'm going to go to the lightning bolt for events. I'm going to scroll down here to where they have a click, and I'm going to select button 1 click for all of them. So now they're all wired up to the same click function. If you click on any of these buttons now, you see I get taken to button 1 click. All right, there we go. Now let's go model, let's go put some constants into our program here. How about we make const int x equals 0. No, how about empty equals 0? Empty const int. Yeah, we could make these enumerations. Is that going to mess anything up? No. let's be sneaky and let's use an enumeration. Let's enum I don't know, enum, what do we call this thing, a symbol or something? I'll call it a cell value, and we'll have empty x and o. There we go. And then let's define whose turn it is, and we'll know we can use a cell value for that. Cell value turn. And then the question is, like, if we don't give it an initial value, it's going to be set to empty, and we probably want it to be either x or o. So there we go. Equals cell value dot x. So that's the kind of annoying thing about enums, is that you always have to prefix them with the name of the enumeration. So it's almost like this is a class, and these are static const members of that class. That's kind of really what an enumeration is. It's a wrapper around a bunch of constants. And then lastly, we need the board. And that's going to be a two-dimensional array of cell values. So let's give ourselves a cell value two-dimensional array. So how do you do a two-dimensional array in C#? There's only one set of square brackets, and you put a comma in the middle to indicate that there are two indexes. And then let's give it a name called board, and then we have to allocate it, because arrays are reference types. Until we use a new operator, we have not actually created our array. So there we got a 3 by 3 grid of cell values. And are we've got whose turn it is, and I think we're good there. Yeah, all right. So let's make a function to reset our board and clear and set all the buttons back to an empty string. So I'm going to make a void function called reset. So we want to write the function that clicks on the button, but that's going to require that we have the reset function and a function that checks for a win. So we've got to write those functions first, and then finally write the function that would use both of them. So what we're going to do here is, whereas with a one-dimensional array you would have one for loop, with a two-dimensional array you need two for loops. And you might be wondering, could we use a for each loop for this? And the answer is no. And that happens to be because our array is made up of enums, which are value types. So as we were iterating over this thing, we'd actually be trying to modify a copy of the value in the array rather than the thing itself. So if we had a two-dimensional array of reference types, then we could use a for each loop. But because our two-dimensional array contains enums are value types, that would not work. So let's set the board at ij equal to cell value dot empty. All right. So we've cleaned out our board, and we also need to reset the buttons. So how do we do that? We could do button1.text equals blank, button2.text equals blank, button3. That's horrible. It's really boring. There's a much easier way to do it, and that's using the fact that the form has an array of its controls, or it's not an array. It contains a collection of its controls, and it's called controls. So we can loop over all the controls that are on the form, test if that control is a button. If it is, set its text property to blank. So there we can use a for each loop. So we'll say for every control C in controls, boom, there we go. Well, what do we want to do to C? First of all, we want to test if it's a button. How do we test if it's a button? We'll get to this when we do polymorphism, but in C++, this is your dynamic cast operator. It's like try to cast this thing to an object, and if the cast is invalid, return null, something like that. We can do that in C# using the is and as operators. This is a much nicer thing than the dynamic and static cast that you've got in C++. So let me show you how that works. We can say if C is a button, right? So that's it. That's our dynamic cast. C#, really nice like that. So this will return false if C is not a button. It will return true also if it's a button or any subclass of button. If we made our own particular button class called Tic Tac Toe button or something, A tic-tac-toe button is a button according to polymorphism. So that would still return true. Okay, well then what do we want to do? We know that the control is a button, and then we can set its text property to blank. There we go. So we've reset all the controls there. Okay, now let's write a function to check to see if somebody is 1. This will return true or false, so that's a bool. We'll call it check win. And I don't know, do we need a parameter? Probably not. It'll just, yeah, we don't need to say like did O win or X win, because what we'll do is after we put a X or O on the board, then we'll call this function. So there's 8 possibilities we have to check for. We've got to check rows, columns, and diagonals, and there's no real easy way to do that, except, you know, tic-tac-toe is small enough that brute force will work. So here comes the two-dimensional array syntax again. One set of square brackets with 2 indexes on either side of a comma. So if board 0, 0 equals, why did that? Oh, come on, no. What? Board at 0, 1. So no, 1, 0. So we're gonna do the horizontals first. And board at 1, 0 equals the board at Jesus, sorry, there we go. Okay, that works. That means they're all the same. All going across, they're all the same. And now I should just be able to copy and paste that. Or oh, come on, help me out here. Now let's go down 1 row. 1, 1, 1, 1, 1, 1. Or, and then let's drop down to the bottom row, so where the y coordinate is 2, 2, 2. All right, so those are our verticals. I'm sorry, horizontals. And now let's check our verticals. So let's put in, I'll just put in a note here that these are horizontal. All right, now let's do the verticals. Or let's copy one of these guys and just modify it. So in this case, the x coordinate would all be the same, and the y coordinate would be the one that's changing. So 0, 0, 0 and 0, 1 equals 0, 2. So if the top left one equals the one middle halfway down on the left side, and that equals the one on the bottom, that is a vertical. And we'll just copy and paste that and move over 1. And finally move over . And then we've got our diagonals. So that'll be the top left, the middle, and the bottom. There we go. And then the other one is going to be over 0, down 2, over 1, down 1, over 1, down 1, over 2, down 0. So if either of those are true, any of that's true, return true, return false. So if it wasn't true, it's going to fall through here and just return false. I could put an else there. I don't need to. All right, so there's our function. Hopefully that's all good. I probably made some mistake in there somewhere, though. Okay. And now let's, now that we've got our check win function, we can finally fill out the button one click function. So let's go to that. And what we need to do is first check to see if the control that we're trying to click on hasn't been clicked on already, because that would be cheating. Back to button one click here. Sorry, barking dog. We want to check to see if the control has already been clicked on. So how do we get the control that was clicked on? That's what this thing is. So object, which is the root of the C# class hierarchy, is the parameter, and we know that this thing is a button, so we can typecast it to a button. So now we have that thing as a button. And just another way we could have done this in C# is B as button. That's another way of sender as button. There we go. So convert sender to a button. That's another way of doing that in C#. Okay, so let's just do it kind of the C++ way. Convert C to a button. Sender. And now that we've got that button there, we can test its text property. So if b.text is equal to blank, it's an empty string, then we can go change the value of that control. So let's see whose turn it is here. We can say if, there's probably a more streamlined way to do this. All right, well, yeah, let's just, so we can, what we can do is, no, we can't. All right, let's, sorry. If the turn is equal to cell value dot x, then x will move, otherwise O will move. So what do we want to do? We want to put an X in the button. So let's change its text property to be a capital X. And then we need to change the grid to match. We need to put a correct, the corresponding value in the grid so that the grid stays in sync with what's shown on the form. So in order to do that, let's go back up here right before we start to do our stuff with the buttons. What we need to do is get the row and the column of the control that got clicked on. And here's where we're going to do our sneakiness. Remember, the control number is kind of embedded in the name of the control. So what we can do is get the control's name, and then we can chop off the last character. And I'm going to make a string called suffix. So this is the last character on the button's name. So b.name.last. Now this returns me a character. Unfortunately, I tried this with converting a character to an integer, and what it did was it gave me the ASCII value of the character rather than like it would convert 1 into like 49 or something, you know, like the ASCII value for the character 1. I want a 1. So that's a little bit different. So in order to convert get what I want here, I need to convert this thing to a string rather than a character. It was kind of a weird, subtle problem. So get the last character off the control's name as a string, and then we can convert that to an integer. So I'm going to make an integer called control number, and I'm going to use convert.toInt32. Remember we did that when we were doing Fahrenheit stuff. Oh, not an unsigned in. Actually, it would work unsigned too. And then what do I want to convert? The suffix. Now I've got an interesting problem here. The buttons start getting labeled at 1, but the array indexes start at 0. So there's the button names they're 1 off from the array indexes. So I need to subtract 1 off of my control number, because button 9 is really, corresponds to the 8th control if you were talking about an array. All right, and now that we've got the control number, we can do the modulus and the division to get the coordinate. So let's get the row. The row is the x coordinate, and we can get the x coordinate by using the modulus operator. So divide that by, modulus it by the width of the grid, and that'll get and take the remainder, and the remainder is the x coordinate. And if we just do a regular division, we get the y coordinate. Okay, and now that we've got the row and the column, now we're kind of all set here. So let's go into our little block where we're going to change the value of the grid. So we can say, actually we could do that up here too. Grid sub, that's not grid, it's board. Board sub row sub column equals equals whoever's turn it is. There we go. All right. And then we can put an X in the box. And then let's call our check win function. And we can say if check win, message box dot show X wins, and then call reset. And then the bottom part will just be a mirror of that, right? So put an O character in the box, check for win. O wins. All right. I'm afraid to run it. There's always something wrong, especially when I speed code. X wins. Why does it say X wins? X wins. So there's obviously something very wrong here. All right, I'm going to pause this and see if I can figure out what it is. All right, this was a stupid problem that only took 2 seconds of staring at to solve. Okay, what this check is doing is saying, are they all equal? And look at this board. Are they all equal? Yeah, sure they're all equal. They're all set to empty. So there's the problem. We have to check. We have to do another check to see if we have to check to see if the first cell that we're checking is in fact empty. That's a required condition. Oh, no, come on. So let me go make all of those fixes here. And it looks like there's another place down here where I'm using 02, so I'll put that down there. And there was a place up here where I was checking 00. It's always something. All right, now here we have board. Board 10 and board 20. Okay, let's try that and see if that works. So we had to add the extra check just to make sure that they're not empty. Oh, what did we forget to do? Flip the turn. Okay, let's go back and flip the turn. So after we in button one click, we can flip the turn here. We could do it. We probably want to do it. Well, let's just do it down here. Oh no, let's do it in here. So we can say turn equals cell value dot X. So now we put an O in the box, and now it's X's turn, and put we put an X in a box, so now it's O's turn. So now let's just try that and see if it works. Boom, 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 boom. All right. I call it. I claim victory. All right, there we go. So there's how to do tic tac toe as a WinForm application using a two-dimensional array. just the key thing here is that two-dimensional arrays are great for modeling situations where you've got grid that's kind of in tabular form. You have two indexes, and then just keep in mind that the syntax is a little different from C++. Rather than having two sets of brackets, you have one set of brackets with the comma separating the two indexes. So there you go. I will kind of scroll down and put that there, and you can hopefully freeze frame that, and that will help you figure this out. All right, thanks for watching. Hope that was helpful.